Hello dear students, good evening to each and everyone, and all of you are welcome to Wallah English YouTube channel. We are studying signals and system in comprehensive manner. Already we completed 2 lectures and this is lecture number 3. We are studying chapter number 1, Introduction to the Signals and System. Till now we have seen definition of signal, types of signal based on nature of variables. There are 2 types of variables: independent variable which is on x-axis, that is time, and dependent variable which is on y-axis, that is amplitude. Now this time can be continuous or it can be discrete also. Similarly, amplitude can be continuous or it can be discrete. Fine. And in last class I taught you about some standard signals, and first we started the unit step function, guys. Unit step function or step function. Okay. So tell me, am I audible? Audio and video both are clear now? Am I audible properly? Audio and video both are clear or not? In comment box tell me, am I audible properly? Yes. Chaliye. Great. So let us continue further. Guys. Unit step function. So today we will study some standard signals and this is part 2. Unit step function. Suppose I am asking to draw x of t equal to 2 q of t minus 2 q of t minus 4, guys. Q of t minus 4. Then what will be your answer, guys? So here so one step signal is starting from t equal to 2, guys, and one more starting from t equal to 4. So t equal to step function having amplitude 2, guys. It will maintain constant amplitude till next signal, and t equal to 4, one more step function is coming with amplitude minus 2. So previous amplitude is 2, guys. Previous amplitude 2, and at t equal to 4 amplitude is minus 2. Present amplitude is minus 2. So previous plus 2, present minus 2. So what will be the next amplitude? That is plus 2 minus 2, it will be 0, guys. You have to add previous amplitude and present amplitude for the next amplitude. So it will be 0 in this case. It will be 0. Amplitude is 0. Fine. Amplitude is 0. So you will get this type of rectangle function. Guys. Correct? Amplitude can be negative also, guys. Suppose I am asking to draw x of t, suppose minus 3 q of t plus plus 3 q of minus 6. Okay. Then how to draw this, guys? So here you can see rectangle function between 2 and 4 with amplitude 2, guys. Rectangle function between 2 and 4 with amplitude 2. So here what we can write? You can take minus 3 common, guys. Minus 3 common. So u of t plus 2 minus q of t minus 6. Now this step function is starting from t equal to minus 2 and this t equal to 6. So here you will get rectangle function from minus 2 to plus 6 having amplitude minus 3, guys. Having amplitude minus 3. Graphically it looks like this, guys. Looks like this. Okay. So from minus 2 to plus 6. Rectangle function minus 2 to plus 6, amplitude is minus 2. So amplitude is minus 2 plus 6, this origin, and amplitude is minus 3. Amplitude is minus 3. Correct? So this type of question they can ask, and this is the fundamental, guys. Okay. If the fundamental is clear, then difficult topic further you can understand very much easily. Any doubt in this? Tell me. Any doubt? Okay. Okay, Manthan. Yes. You are also from Gujarat. Okay, great. That's great. But mechanical branch. Okay, no issue. This is for electronics and communication and electrical and for instrumentation also, guys. Okay. Now see here. Suppose I am asking draw. Suppose I am asking draw. Now suppose I am asking to draw one more question. Now this is very much important. X of t equal to x of t, which is equal to uh, q of minus t plus minus q of minus t plus 2. Then what will be your answer? What will be your answer, guys? U of minus t plus 4 minus u of minus t plus 2, guys. Okay. Now see. Now this is the step function starting from 4 and going towards left side, because I told you guys minus t, that means left side signal, and starting point will be the same sign plus 4. It will start from plus 4, t equal to plus 4, and going towards left side amplitude 1. Similarly here, start left side signal starting from plus 2 and going towards left side. So here we draw this one, guys. First signal is the, now here second signal, and this is the third signal. So here q of minus t plus 4, this is q of minus t plus 2. Okay. So this starts from plus 4. Okay, this start from plus 4 and going towards left side. Minus, that means left side. It starts from the plus 4, same sign. Amplitude is 1, guys. 1. Similarly, this starts from guys, starts from 2, amplitude is 1. Okay. Now subtraction. So what will be your answer, guys? What will be your answer? So here this signal minus this equal to this. So you can see, guys, you can see here from minus infinite to 2, guys. Here from minus infinite to 2, amplitude is 1 minus 1, here 0, guys. Correct? This is, so here I am writing is 4. Okay. So this is 1 minus 1, here 0, guys. Now next, here similarly 0 minus 0, guys. 0 minus 0, again 0. So for t less than 2, amplitude is 0. For t greater than 4, amplitude is 0. Now in between 2 and 4, so here amplitude is 1 minus 0, so amplitude is 1, guys. Correct? So again you will get the rectangular function between 2 and 4, guys. Rectangular function between 2 and 4. Correct? I hope all of you are getting what I am saying. So this is 4, guys. So again, so 1, 3 points. Okay. So this 1 minus 1, 0, guys. Resultant signal is 0 here. 0. Then again greater than 4. 0 minus 0, 0, guys. And again between 2 and 4, 1 minus 0, it is. Correct? So this will be your answer, guys. Will be your answer. This is your x of t. Now here can we write like this? This is nothing but This is nothing but what? Can we write like this? This x of t is nothing but, so it is starting from 2 and 4. Can we write like this? It is nothing but u of t minus 2 minus u of t minus 4. Yes or no? You can see here. You can write this graphical signal mathematically like this also, guys. This also. See here. Here. U of t minus 2, u of t minus 4, amplitude is 2, guys. So between 2 and 4, amplitude 2, guys. Here, this is between 2 and 4, amplitude 1. So that's why u of t minus 2 minus u of t minus 4. So this both graphical representation is same, but mathematically both are different. So here conclusion is what? u of t minus 2 minus u of t minus 4, which is equal to minus u of minus t plus 2 minus u of minus t plus 4. Now see, what is the important observation from this question? What is the important observation? You can see the important observation. Here you represented in the right sided signal. This is right sided signal, this is right sided signal, correct? This is the right sided signal, the right sided signal, because plus t right sided, plus t right sided. And here you can see, guys, this is the left sided signal, minus t, that means left sided signal, this is also left sided signal. Okay, so here you can represent this graph, you can represent mathematically the expression for this graphical signal. This also valid and this is also valid, guys, correct? Here, sorry, plus guys, this plus, correct? So what you have to do, guys? What you have to do? Simply you have to change the sign of amplitude. See, first is what? If right sided representation is there, if you have right sided representation, then how to write the left sided representation? If you have right sided representation is there, then how to write left sided representation? So first of all, there is a opposite sign of amplitude, guys. You have to change the sign of amplitude. You can see here plus 1, then here it is minus 1. Here plus 1 amplitude, then minus 1 amplitude. Here minus 1 amplitude, here plus amplitude. So simply you have to change the sign of amplitude. First observation, you have to change the sign of amplitude. In the similar manner, you have to change the sign of internal this independent variable also. You can say t become minus t, minus 2 become plus 2, t become minus t, and minus 4 become plus 4. You have to, in short, you have to change the sign of amplitude as well as sign of the independent variable also, guys. You have to change the sign of amplitude and sign of variable which present in the bracket. Variable present in the bracket. T minus 2 is variable, t minus 4 is variable. So you have to change the sign of t minus 2. So it become minus t plus 2. You have to change the sign of t minus 4. So it become minus t plus 4. Then it will convert into left sided, and this is also valid. So they can ask in multiple select question also, guys. Multiple select question also. Suppose now I am asking, guys, write the mathematical expression for this graphical representation of signal. So here x of t, one, guys, one. Zero is 4 minus 1. Suppose amplitude is 3, guys. Amplitude is 3. So first you have to write the mathematical expression for this. So first option is right sided, both right sided. So this is right sided, this is right sided. Then x of t will be right sided. For right sided, it is 3 common. U of t plus 1 minus u of t minus 4, correct? It is very much easy, guys. This is very much easy for all students. Right sided signal, you can see the right sided, okay, right sided, guys. Starting t minus 1, so that's why you have t plus 1, ending 4, so t minus 4. Now what about left sided, guys? Left sided left sided. So second left sided, that is you have to change the sign of amplitude. So sign of amplitude here, this is 3. So here sign plus 1, that's why minus u of, now minus t minus 1, correct? You have to change the sign of amplitude as well as this variable present in the bracket. So minus t minus 1, minus become plus, and u of again minus t, t become minus t, minus 4 become plus 4. This is the important shortcut. So this is also valid representation, both left sided, left side, left side. This is also correct, this is also correct. Now one more representation is there, guys. One more representation is there, correct? One more representation. First of all, tell me, is this clear? Any doubt till here? Any doubt till here, guys? Is this clear to each and everyone? This is very much important concept, guys. This is very much important concept. Now what I am saying, guys, what I am saying, one more important observation. See, u of t, and this is, suppose this is a rectangle function from rectangular function a to b, correct? A to b, rectangular function from a b having amplitude. This a and b, it can be 0, it can be positive, negative, anything, correct? Anything, guys. A b, both positive, both negative, one positive, one negative, one is 0, another is non-zero, like that. So here the x of t is so first x of t is equal to, amplitude is k, right sided, so u of t minus a minus u of t minus b, correct? The right way. And one more, left sided. So for left sided, you have to change the amplitude. This k, now plus amplitude become minus, you have to change the variable also, minus t plus a, and here minus minus plus u of minus t plus b, guys. Got it? Got it? You getting what I'm saying? Now one more. See, this is right sided, left sided, left sided. One more, guys. Now u of t minus a, guys. U of t minus a into u of one right sided and one left sided, guys. One right sided and one left sided. See, one right sided and left sided. Here both right sided, both left sided. Now next is one right sided and one left sided. What I am writing, guys, see, b greater than a, guys, b greater than a here is u of so here this is a, guys, and this is b. Now multiplication, guys. So first is what? U of t minus a. Second is u of going left side, that's why minus t, left side, that's why minus t, and plus b here, correct? This is right sided, that's why u of t, and starting a, opposite side minus a. This is going left side, so that's why minus t, and same sign plus b, so plus b here. Now multiplication, guys, multiplication, amplitude multiplication. So here is suppose k, okay. Now here multiplication, amplitude multiplication. So 0 into 0, guys, then 0, then again, sorry, 0 into 1, 0, guys, 0 into 1, and this is 1 into 0, that is 0, guys. Now here 1 into 1, which is nothing but 1, guys, again rectangular function you get, correct? So less than a, guys, less than a, this a, b, guys. So less than a, what is the answer of the multiplication? 0 into 1, so it is 0, guys. Greater than b, 1 into 0, amplitude multiplication 0, 1 into 0, 0, and between a and b, 1 into 1, guys, between a and b, 1 into 1, that is 1, guys, 1, correct? So this is also valid. here amplitude is 1, here amplitude is 0, amplitude is 0, here 1, here 1, here 1, 1, amplitude 0 guys. Here amplitude is 1, is 0. So this is also correct representation, but this time the multiplication. So this is right sided signal, left sided signal. So here third representation also guys, mathematical representation. So here A is amplitude, so bracket u of t minus a into u of minus t plus b. So these all are 3 correct. This is the right sided, left sided, the right sided and this is left sided. Fine. So this is very much important guys. They can ask in multiple select question also guys, multiple select question also. So in this question one more representation, this is right sided and this is left sided, correct. Both right sided, both left sided, and one right sided, one left sided. So number 3, lower limit, lower right sided, upper left sided. So x of t will be amplitude is 3 bracket u of right sided, so t plus 1 guys, right sided plus t opposite sign, minus u of left sided minus t same sign, so plus 4. So this is very much important guys. This is right sided, this is left sided. Okay, this is very much important question. So three answers are possible in this question. Fine, 3 answers are possible in this question. Any doubt? Any further doubt? Okay, great. I hope all of you are getting. I hope all the students are getting. Fine, correct. So this is very much important observation. Very much important observation. And this is general guys. This is general. Okay. So this thing you can write in the short notes also. Short notes also guys. Okay. First you can write the right side representation of this graphical signal. Then you can write in left side also. Just you have to change the sign of amplitude as well as sign of variable present in the bracket. Okay. Now this is all about step function guys. This is all about step function. Later we will see how to write mathematical expression from the graphical representation of the signal. Correct? After completion of the triangular function or ramp function, we will see guys. Now next standard signal I am going to take is rectangle function or gate function, or it is also known as the pi function, or it is also known as pi function, or it is so known as the pi function. Fine, pi function. Now see, first of all mathematical representation, graphical representation. So x of t equal to rectangular function guys. So here a rect t upon capital T, where a is amplitude, small t is the independent variable on x axis, and capital T is the width of rectangular pulse. Width of rectangular pulse guys. Okay. It is also defined as a pi function, pi capital T. Both notation you have to remember. A rect t by t, that means rectangular function. A pi t by t, that is also rectangular function, and sometimes it is also known as the gate function. So here a rect t upon capital T is equal to amplitude is a between minus t by 2. This is the standard format guys. Standard for minus t by 2 and t by 2, and it is equal to 0 otherwise. Correct. So here amplitude is a between minus t by 2 and plus t by 2. So here you can see guys, between t by 2 and minus t by 2, amplitude is a guys, constant amplitude a, and greater than t by 2 and less than minus t by 2, amplitude is 0 guys, amplitude is, got it? And here this is the pulse width guys, this is capital T is pulse width, A is amplitude and T is nothing but we can write the pulse width here, pulse width, correct, pulse width. Now here can we write like this, is also correct way mathematically, A rect by capital T equal to A for T less than T by 2, which is equal to A for T greater than minus T. So here you can write A minus T than T by 2. Now observe this one guys, T less than capital T by 2 minus T less than T by capital T by 2. So here can we write like this, can we write like this, A rect, very much important, this is A, you can write mod T guys, mod T less than T by 2 guys, and it is 0, it is 0 for mod T less than 0. This is also valid guys, this is also correct representation mathematically, this is also correct representation guys, fine. So here this is also correct representation. Is this clear to each and everyone? This is also correct representation. Okay, so you can write like this, A between minus T by 2 and plus T by 2, or we can write like this also, it is equal to A where mod T less than T by 2 guys, and not 0 guys, this is T by 2, not by 2, my mistake, here this is T by 2 guys, my mistake. So again same thing. Now you can write this signal into the step function also guys, step function, both right sided, both left sided, one right sided, one left sided guys. So first both right sided, so x of t is equal to a common q of starting point, so t plus t by 2 minus u of t minus t by 2, correct, this is the correct way. And second both right sided, now left sided, so left sided simply you have to change the amplitude, is there here minus u of, you have to change the sign also, minus t by 2, here minus become plus, u of again sign change, minus t plus t by 2. So this is also correct way. And one right sided, this is right sided and this is left sided, so here lower limit, this is right sided and this is left sided, so x of t is equal to a, this is right sided, so u of multiplication t plus t by 2 into multiplication q of left sided minus t plus t by 2 guys. Okay, so you can represent like this also. So this is all about what guys, rectangular function, this is all about what, rectangular function, fine. This rectangular function you can represent in the step function also, and this is the standard format guys, standard format between minus t by 2 and plus t by 2, this is the standard format. Is this clear? Fine, okay, very good. So this is, I hope this thing is clear to each and every student. Now next standard function is very much important for exam point of view, that is impulse function, or it is also known as direct delta function, continuous impulse function, or it is also known as direct delta function. So mathematically x of t is equal to del t, x of t is equal to del t, which is equal to, ideally speaking, amplitude is infinite as t tends to 0 or t equal to 0. This is the ideal case. This is the ideal case. Amplitude is infinite at t equal to 0, or we can say amplitude tends to infinite when t tends to 0 guys, and here it is 0 when t is not equal to 0. That means this is defined at t equal to 0 only. Sudden change guys, okay, like thunderstorm or lightning, or we can say sudden shock also we can say guys. So for a very small period of time large amount of amplitude is present, very large amount of amplitude present for a very small period of time, large amount of amplitude is present. Okay, so might have seen that lightning in the sky, guys. Okay, lightning this sky in monsoon, that is the example of impulse function, sudden shock guys. Okay, so here graphical representation T. Now at t equal to 0, looks like this, guys. Okay, amplitude is infinite. This arrow indicates, upside arrow indicates, this arrow indicates amplitude is infinite, guys. Amplitude is infinite at t equal to 0 and amplitude is 0 other than t equal to 0, guys. The graphical representation of this impulse function. Suppose I am asking to draw x of t is equal to del t minus 2. So here t become t minus 2, left hand side this t become t minus 2, right hand side also t become t minus 2, guys. Here you are replacing left hand side, left of the equal to t become t minus 2. So right hand side also everywhere t become t by 2. So this symbol we present at t equal to 2, guys. Now this symbol is right shifted, guys. Right shifted. So here, suppose this is the y axis t, correct? So now this impulse present at t equal to 2, guys. Again amplitude is infinite, guys. Same thing, amplitude is infinite, guys. Similarly you can draw for t plus 3 also, guys. T plus 3 also. Now how it is derived, guys? So this impulse function, continuous impulse function or direct data function is derived from the unit area rectangular function, guys. So it is derived from the unit area rectangular function. We have to take area of rectangular function unity, guys. Unity. So let us consider this type of rectangular function. Okay, area is unity, guys. Area is 1. Area is unity. Let us consider this is 0. This is 0. Here this is suppose I am writing -2. This is 2, guys. Okay, -2 and 2. Here area is 1, guys. So this is width, guys. Let us consider this width. Let us consider this is width of rectangular function, height or amplitude A, and this is the width W. So what about area, guys? I am talking about area. So area is equal to A into W, guys. A into W. Correct? Area is equal to A into W, where A is amplitude. Now you have to take unit area, guys. Unit area rectangular function. It is derived from the approximation of. It is derived from the approximation of unit area rectangular function. Derived from the approximation of unit area. It is derived from the approximation of unit area rectangular function. Now here area is equal to 1. Area 1, guys. That's why now we are considering area 1. So A into W, which is equal to 1. Now you can see, guys, if I decreases the width of this rectangular function, if you decrease width of this rectangular function, product is constant, so amplitude is increases, guys. As width decreases, guys, or pulse width, as we decrease this pulse width of this rectangular function, opposite side amplitude will increases guys, the same factor with the same factor guys, the same factor. So here if area is equal to 1, then in this case what is the amplitude? So width is 4, so amplitude will be 1 by 4 to make area 1 guys, make area 1. If width is 4, then amplitude should be 1 by 4. Now I am decreasing this width guys. Suppose now I am taking half width guys, half width, then amplitude will be double, width is half guys. Suppose now now you can see width is 2, then if amplitude see now width is 2 guys and we want area 1, so what will be the guys amplitude? So in this case amplitude is 1 by 2 guys, in this case amplitude is 1 by 2. Again you are decreasing, again you are decreasing, again you are decreasing width guys, W you are decreasing, opposite side amplitude is increasing because area is constant. So here this is minus 1 by 2, this is 1 by 2, so now it is 1. Now you can see guys, as W tends to 0, or we can say T guys, as T tends to 0, amplitude tends to infinite guys, as width tends to 0, so amplitude tends to correct. You can see guys, at the last what will happen, as at the last what will happen. So in this case here for these guys, as W tends to 0, amplitude tends to infinite, because here we are considering unit area. And why we are considering unit area only? Why we are not considering area other than unity? That also I will tell you guys. Okay. For simplicity, I consider area of this rectangular function is 1, and now we are doing the approximation. We are decreasing the width, and as area 1, so amplitude is increasing the same with the same factor guys. Correct, with the same factor. Are you getting? With the same factor. Okay, with the same factor guys, correct, with the same factor. So in this manner we can derive the impulse function. Even we can derive from the approximation of Gaussian unit area Gaussian function, unit area triangular function. Okay, so this is the how we got impulse function. Now we have to see guys the properties of impulse function. Properties of this impulse function, it's very much important. Any doubt till here guys? Tell me. Any doubt till here? You can write your doubt in comment box, because this is very much important. Is this clear to each and everyone? Is this clear? Now important properties of impulse function, this is very much important guys. And same thing is applicable for discrete time impulse function also guys. Same properties. Okay, so if you have doubt, then please ask. चलिए, clear to each and everyone? Okay, so first property is area property, then scaling property, then product property, sampling property, and shifting property guys. Okay, so let us start with very first property, area property. Now if you integrate this impulse function guys, integrate area property, so area under impulse guys, integration from minus infinite. If you integrate any signal from minus infinite to plus infinite, then it gives the total area guys, correct? Total area of x of t, okay, total area of x of t. So now tell me in the comment box, if you integrate impulse function, what is the area under impulse guys? What is the area under impulse? The first property, what is the area under impulse? It will be 1 because it is derived from the unit area rectangular function. It is derived from the unit area rectangular function. So if you integrate this impulse function from minus infinite to plus infinite, because as t tends to 0, amplitude tends to infinite, so area will be unity. Area will be unity guys, correct? You can see here, area will be unity at width tends to 0. Here omega is not the frequency, remember this thing, this is the width w guys. So as w tends to 0, a tends to infinite, so area will be 1. So first property is area under impulse function is unity guys. Area under impulse function is. So suppose I am writing what is area of x of t is equal to a into del t guys, a into del t. So here you have to tell me whether a is the amplitude or a is area guys. Here in this example, this a is area of impulse or it is amplitude of an impulse function. So my dear friends, here a is not amplitude because amplitude of any impulse function is infinite. See, a into del t. So amplitude is always finite, correct? Amplitude is always infinite guys. Fine. But what is a guys? A is nothing but what? Area guys. Area of impulse function. Area of this function guys. Area of this function. To integrate signal from minus infinite to plus infinite. A into del t dt. You can take a common. So minus infinite plus infinite del t dt. Now what is the area of impulse? So area of impulse is 1 guys. So that's why a guys. So here x of t is equal to a into del t. So a is area but not amplitude. Remember this thing, this is very much important thing. Okay, a is area, it is not amplitude guys. Amplitude is always infinite. Then how to represent this graphically guys? How to represent this graphically? So mathematical, each and every parameter of mathematical expression we are writing graphically. So where to write this a guys? Where to write this a, area? So here this arrow indicates amplitude is infinite. Arrow indicates amplitude is infinite, and here I am writing a guys. Here I am writing here a, correct? So this a indicate, see, a is not amplitude. We can say height of impulse function. We can say height of impulse function, or we can say it's the area guys. This is area of a del t, correct? Remember this thing. This is the area of a del t. This is the area of a del t guys, correct? If I am writing here a, so meaning of a is not amplitude. Amplitude is always infinite, but this a indicate area of del t guys. Suppose I am asking to draw x of t is equal to 2 del t plus 3 and minus 4 del t minus 4 guys, correct? So here there are two impulses guys. There are two impulses. One is present at t equal to minus 3 having area 2 guys, having area 2, correct? Having area 2 guys. This impulse is present at t equal to minus 3 with area 2, and this impulse is present at t equal to 4 with area minus 4 guys, with area minus 4. Amplitude of this signal is plus infinite and amplitude of this signal is minus infinite guys, correct? So here this impulse is present at minus 3, is present at minus 3 guys, having area 2 guys, height, we can say height 2 or area 2 guys, and this impulse is present at t equal to 4 guys, t equal to 4 guys. with area minus 4, with area minus 4. So here the height is 2 and height is minus 4 guys. There should be difference between height guys or area guys. Now suppose I am asking what is the total area. So area of impulse is 2 and here area of impulse is minus 4. So what is the total area? Minus 2. Yes, here negative area possible guys. So of course, because signal amplitude is negative, so area negative possible. Correct? In this case, area negative area is possible. Fine? Clear? So negative area is possible here guys. What is the total area guys? What is the total area? So here total area is total area of x of t. So area of first impulse is 2, second impulse is minus 4. So answer is minus 2 guys, minus 2. Okay. Now let me take some question guys. Some question. So here let us solve some question. See. So draw x of t and find the area guys. Draw x of t and find the area. Here scaling property you have to use. Wait, scaling property you have to use. So for that, first of all we have to understand the scaling property of the impulse function. Scaling property of the impulse function. Problem guys. Again. So second property is this scaling property guys. Scaling property. So what is the scaling property of the impulse function? This property says that del time scaling property alpha into t, where alpha is a scaling factor, then it is equal to 1 upon mod alpha into del t. 1 upon mod alpha into del t. Now proof of each and every property is available, but in GATE exam I think proof is not required. Simply you have to remember property and how to use property in the question guys. Simply you have to remember the properties and how to use this property in the question. Correct? Proof is not required. Wherever proof is required, definitely I will tell you guys. Wherever proof is needed, then definitely we will derive the proof also. Okay. So here del alpha t is equal to 1 upon mod alpha del t, where alpha is scaling, where alpha is scaling factor guys, where alpha is the scaling factor. Correct? Alpha क्या है? Scaling factor हो जाएगा. So what is the result from this property? Again I am telling guys, proof is not needed. Simply remember this property. Proof is there but not required, or you can see the proof in standard book also. Okay. Wherever required, definitely I will tell you guys. So if alpha is equal to minus 1, the scaling factor is minus 1, then del minus t is equal to del t. This indicates impulse is a even function. Impulse is an even signal or even function of time guys. Correct? Because del t become minus t, then same you are getting. So del minus t equal del t. So that's why impulse is an even function guys. Impulse is an even function. Now suppose I am asking to draw. Draw x of t is equal to 2 del dt minus 1 guys. What is the position of this impulse and what is the area? Of course, amplitude is infinite, but what is the area and what is the position of this impulse function? So before using the scaling property, first of all scaling factor you have to take common guys. So here x of t is equal to 2 del 3 bracket t minus 1 by 3 guys. Now here this is your scaling factor. Your scaling factor 3 guys. So use the scaling property. So x of t will be 1 upon mod alpha guys. You can see 1 upon mod alpha. 1 upon mod alpha into del t. So here 1 upon mod alpha. So mod 3 into del t minus 1 by 3, which is equal to 2 by 3 into del t minus 1 by 3 guys. So this impulse is present at t equal to 1 by 3, having area 2 by 3 guys, having area 2 by 3, right? Having the area 2 by 3, having the area 2 by 3. This impulse is present at t equal to 1 by 3 with area again amplitude is infinite. Remember amplitude is infinite, but area is 2 by 3, and 2 by 3 I have to write this here guys. This 2 by 3 indicates area of impulse is 2 by 3, not amplitude guys, not amplitude. Okay. Similarly, suppose I am asking to draw x of t, which is equal to minus 3 del minus t by 2 plus 1 guys, plus 1. Then tell me what is the area of this impulse function and what is the position where this impulse is located, guys. So again, before using the scaling property, first of all we need to take common scaling factor common. So minus 3 del, what is the scaling factor? Minus 1 by 2. Take minus 1 by 2 common, and here t minus 2 guys, yes or no? Now here your scaling factor alpha is equal to minus 1 by 2. Now the scaling factor alpha equal to minus 1 by 2. So here x of t, which is equal to minus 3 divided by mod minus 1 by 2. See, 1 by mod alpha guys, 1 upon mod alpha. So 1 upon mod minus 1 by 2, as alpha is minus 1 by 2, and del t minus 2. So this impulse is present or located at t equal to having amplitude guys. It is nothing but 6 del, minus 6, nothing but minus 6 del t minus 2. So amplitude is infinite, area is minus 6 guys, area is minus 6. What is the graphical representation? What is the graphical representation? So this is t, impulse is present at t equal to 2, guys, t equal to 2 with area minus 6 guys. Is this clear? Is this clear to each and everyone? Tell me in the comment box. I hope all of you are getting what I am saying. I hope all the students are getting. Tell me, comment box, is this clear to each and everyone? Is this clear to each and every student? Okay. Now we can solve this question, and we can write the important result also guys. Important result also. You can write the important result also. Time scaling property. Okay, so this is the time scaling property. Now important result. Important result. We know that del alpha t equal to 1 by mod alpha del t. Here del at minus b. What is the answer? Del, first of all, a common, t minus b by a guys, b minus b by a, which is equal to del, which is equal to, here scaling factor is a 1 upon mod a del b minus b by a. Finally, what is the result? Result is del at minus b is equal to 1 upon mod a del b minus b by a guys, del b minus b by a, correct? So this is the important result that you people have to remember. Correct? This is the important result that you have to remember guys. Important result from this scaling property. Now we can solve this question guys. Now we can solve. Question number 1. Question number 1. They are asking to draw x of t guys. They are asking to draw x of t, or they can ask to find the area of x of t guys. So here of t minus 3 del minus 1 by 4 scaling factor t minus 12 guys, correct? Are you getting? Minus 1 by 4 is the scaling factor, take common, take this scaling factor common, so minus 1 by 4, so t minus 12. So here alpha is equal to minus 1 by 4, so x of t will be minus 3 divided by mod minus 1 by 4 del t minus 12 guys. So x of t is equal to, it is minus 12 del t minus 12, correct? T minus 12 guys. So this impulse is present at t equal to 12, having area minus 12. Area minus 12, amplitude is in minus infinity. This impulse present at t equal to 12 is 0, 12, here minus 12. This minus 12 indicate the area guys, indicates area. Is this clear? First question guys. Fine. Now let us solve the second question. Second question, draw x of t, or they can ask to find area of x of t guys. So x of t equal to 2 del, here 1 by 3 scaling factor common, bracket t plus 3 minus 4 del, the scaling factor minus 3 by 2 guys, correct? Now the scaling property, time scaling property, 2 divided by mod 1 by 3 del t plus 3 minus 4 divided by mod 2 del t minus 3. So this impulse is present at t equal to 3 by 2 with area 2, and this impulse is present at t equal to minus 3 with area 6 again. Is 6 del t plus 3 minus 2 del t minus 3 by 2. So graphical representation. This impulse is at minus 3 with area 6, and this impulse is 3 by 2, area minus 2, present at minus 3 at 3 by 2 with area 6, area minus 2. Total area, if I am asking total area of x of t, is equal to 6 plus minus 2 will be 4. Total area will be 4 guys. Total area will be 4. Fine. Total area will be 4. Is this clear? So these are some basic example based on the properties. Later we will see. Got it? Fine. Okay. So guys, let us finish this lecture here, and I am giving one question for guys. Solve this question. Solve this question. Work guys. Work. Number 3. So try yourself. Try yourself guys. Work. X of t, and you have to find the area of x of t. Question number 4 also homework. Number 4 homework. You have to draw x of t, and you have to find the area of x of t guys. Okay, fine. So guys, let us finish this lecture here. Let us finish this lecture here guys. In next class we will see the next signal, that is the next properties of the impulse function. Product property we will see. Then we will see the scaling, sampling property, then shifting property, and we will see the some important results based on this property, and then we will solve number of questions. We will solve total 20 questions based on these properties, and it's a very much important. Same property is applicable for the discrete time impulse function also. So whatever topic we will study for the continuous time signal, same topic we will study for the discrete time signal also guys. Suppose we are taking, or we are consuming 6 hours to understand continuous time signal concept, then it will take only 3 hours, that 50% of 6 hours, that is only 3 hours to understand discrete time signal, same discrete time signal concept. Okay, so guys, understand concept of continuous time signal very carefully, correct? Okay, so guys, thank you so much watching me live on Wallah English channel, and please provide your valuable feedback in comment box after completion of this session. Next part we will continue into subsequent module. Thank you guys, thank you so much.